All right, I guess we're live now. Welcome everyone to Devfest Algiers 21. I hope everyone is excited. I have here with me Paul. Paul is lead for Chrome Developers Relations at Google, and he will be speaking today with us at Devfest Algiers. We'll be having two talks. We'll start with Paul and then we'll go with Justin. So stay with us until the end. Okay, so Paul's talk will be about the future of the web platform, and it will be about 30 minutes talk. And we'll have your questions live, or even if you would like would like us to have them while he's presenting, feel free to drop your questions right on the comment section.
Yeah.
All right, I guess we can start right now, Paul. If
all right.
Everything is all set.
We're good? Brilliant.
Yeah.
It's nice to meet you, everyone. I can't actually see you at the moment. It's the problem with being virtual. It's kind of hard, right? So my name is Paul. I lead our developer relations team on Chrome. And I kind of wanted to spend some time today talking about the future of the web. And I don't know whether the slides are presenting just yet, but you'll see that it says it's behind the scenes of the Chrome Dev Summit at this point. And I think the reason behind that, at least anyway, is because when I plan out things like the Chrome Dev Summit and all these events, like we're trying to look ahead for like what we think web developers should be focusing on in the year ahead. And so I want to give you a little bit of behind the scenes, because you can always go and watch the Chrome Dev Summit and kind of see everything. I want to give you a bit of the reasons why we chose what we did, basically, is the behind the scenes for that. So that's what I'm going to focus on today.
Yeah. All right. I guess we can start with your talk. If you can share your screen, Paul, and you can go ahead.
Yeah. Do I have to do anything special? It's attached, at least. So I'm assuming someone else is going to be able, who can sort this out. There we are. Perfect. So yeah, definitely feel free. I don't know how this is going to fully work in terms of questions, but if people want to, we can drop questions in. I'm always happy to kind of stop and answer any extra things as we go along. But yeah, anyway, I'm going to give you a quick look at behind the scenes of the Chrome Dev Summit, because that really is how we're starting to think about how we think about the future of the web, at least anyway, on that side. And so I think I just kind of want to start, and I can't press the right button at the same time. There we go. I think the interesting thing for me, we took these screenshots ahead of time, just before the Chrome Dev Summit. It's kind of nice to see people kind of interested in and relying on the web right at this point. We're in the middle of the second year kind of a pandemic at this point, and it's been really hard for people to kind of connect and be with each other. And we're at a point now where we are seeing more and more businesses go online, people go online, especially for the first time, than ever before, ever in history on that side of things. And I think it's kind of pretty nice, right, where it's like you've got the leaders of really big companies, your Twitter, and then also kind of Box as well, just saying like, the web is probably the most powerful platform. We can do so much in the web platform as well. And I'm not going to dive into all of the things that you can do today on the web. There's a lot, like if you look at things like web.dev and some other programs or projects we've got running, you'll kind of be able to see that. But I want to be able to talk about kind of, what we're excited about and where we're trying to take the web platform as well. I think fundamentally for us, we have this kind of constant tension between, what users need on the web and then what developers kind of want and need as well. And I think the thing for us is there's a real expectation that people have with the computers that they use and the software that they use on those devices. And, for a long time, it's been kind of, a native app world, a world where kind of, you can only deliver the best experiences on the web. And I think there's a change that's come in the ecosystem, like the capability and the richness and the expressiveness of the web. It's like we've never seen before. But, the bar that users expect is high, and it's very hard for us to deliver, high quality experiences on the web. And I think things are changing, and I kind of want to lead through some of where we're going in the years ahead, at least anyway, in that space. Because, my biggest focus is the developers. I want developers to build great user experiences, but it's kind of hard. And one of the things here is like, this is like secret behind the scenes information. We don't publish this really publicly. We do surveys with developers, like a random sample of developers every single year. And like the biggest thing that they tell us is that there are a number of areas where they struggle. Like developers struggle every single day. They struggle to keep up with the changes on the web platform. They struggle to keep up with the ecosystems that they use. I'm not going to pick on anyone, but like, for instance, say if you're a React user, that system is so vibrant and it changes every single day that developers struggle. We all struggle to kind of keep up with what's happening. And then I think the bigger issues that developers have as well, just as big, I suppose, developers are struggling with very real world issues, that we as Chrome don't always look at and don't consider properly. And so, one of these things is like testing across browsers. Like, should you, or making experiences work across browsers and testing across browsers. And the thing here is like, on one hand, you have to have a Mac to be able to test on an iOS device at the moment. That's hard. That puts up some hurdles as well. But you also have to test across Firefox. You have to test across Chrome, multiple different kind of instances of different types of Chrome browsers, whether it's Edge, Brave, and all these other ones. Like the work that you have to do as a developer, it's hard, right? It's really hard. And then on one side, you've got us, the Chrome team, talking about all these amazing new features that you can use, really just in Chrome. And it doesn't necessarily resonate too much. And so this is what we've been thinking around kind of like the work that we're going to do in the next year. It's actually going to be grounded and based in much more the needs of the ecosystem as well. So I think that's good. I think that the thing here is like this is literally the mission statement that we had for the like when we were pitching Chrome Dev Summit again this year. We wanted to have Chrome's moment. It is about Chrome mostly, the Chrome Dev Summit. But we wanted to kind of make sure that developers and decision makers have the clarity just to build, kind of to know what to build on the web so that you can target high quality sites and apps. And like I think that was actually an important focus for us because we were quite clear about who our users are, like the developer ecosystem. It's not everyone in the world at this point. And then like our goal ultimately is to kind of enable you to build good sites. And I think this is the other bit as well. Again, this is from our pitch deck for like how we're going to get funding for Chrome Dev Summit. And it's like, our overarching theme is high quality experiences and you can do it easily. That's kind of roughly where we're trying to get to. Whether the Chrome Dev Summit itself achieved that goal, I don't know. You can be the judge of that. But I think this is where I'm thinking about the future of the web platform for us, is that we just want to make sure it's as easy as possible for developers to build high quality sites and experiences. And if we don't choose that, and we don't achieve that, then developers will choose different platforms to kind of go to on that side. And again, this is just, a bit more behind the scenes. Like we had these like 3 goals for the platform, or for the event, at least anyway. Improve developer clarity. Like the whole bit about it for us at the moment is it's too hard for you as developers to know what to focus on and how to, why you should focus on these things. We wanted to kind of make sure that the initiatives that we think are important are clear and you can understand why they're important to us as well. So you'll see in a minute, like kind of some of the summaries from things like Core Web Vitals, Privacy Sandbox and Advanced Apps, the PWA story. Like these are 3 really important components for us in terms of how to build high quality sites. And so we wanted to make sure that developers had all the information they needed to go to succeed. And then we wanted to kind of give a little bit of a sneak peek to some of the newer features that are coming through. I think the latter piece we pulled back a little from, just because there's a lot happening, and like the more we add to the keynote and the more we add to the event, the harder it is to kind of understand where the focus should be. But there are some really nice announcements that we had as well around kind of the new responsive, which we'll probably get into in a little bit as well. And I think finally, again, this is very business kind of talk. This is how I pitched it to our leadership as well. Like the event format is, it's a change from previous years where like Chrome Dev Summit was all about this big event where people would go to it and then they would watch maybe 20 different talks that we had. We tried to have a story across them. And then maybe you'd be able to kind of interact with the Chrome engineer. And because we're virtual and we're not, and we're kind of running it live at the same time, we changed it up. Like we found that developers are pretty bored with online, I think this online event's going to be great, right? But like, oh my God, I need to like developers are struggling with kind of like just everything being online right now. There's a definite component of being able to meet people in person is a really important thing. But we can only do what we can do, and like travel's kind of off the cards for a lot of things. And so instead of having to ask people to sit around their laptop for 10 hours, or actually it was 2 days normally, so like 15, 20 hours in total for normally. We just wanted one little keynote that was relatively short, that gave you a summary of what we're going to try and do. And then actually the more important thing is you have all the rest of the kind of the activities around Chrome Dev Summit. So you may or may not have seen some of the stuff that came through, but we had maybe 400 different office hours. So like 400 hours of time where people could interact with the Chrome team at any one particular time. And then we focused on things like, learning lounges and workshops where we'd bring in like industry experts to show you how to build a site that worked really well across browsers. And I felt that was the important thing for me, because I think people don't like being talked to that much, right? Like they want to be able to kind of get their hands on, tools, technologies, and kind of build stuff, right? And so that's what we're looking at. And I think when I go into kind of like, that was the kind of the what it's going to be, how it's going to run, like the what of the event. We've got a number of areas where we're focusing on over the next year, around kind of like we think all the developer ecosystem could or should be excited by, and we think where the web is going. So this is the future of the web bit. I think that the biggest thing for me, and we did get some of this wrong in the event, and you might have seen some kind of articles or at least tweets come through, but we had this kind of focus on compatibility. Like we know developers struggle with building experiences that work across browsers. One of the number one reasons why that happens is, it's very hard to build a site, whether it's through CSS and JavaScript, I suppose at this point, that doesn't, you don't stumble over kind of incompatibilities inside the browser. And so we'd started this project called Compat 2021, which focused on 5 core core areas inside kind of the layout and design space, CSS in particular, that we wanted to make sure that every single browser improved upon in the year ahead. And so we actually think we've done pretty well, but it's one of those stories that you don't really hear too much. We like to talk about it now because I think I'm pretty proud of the work that the team has done behind this, but ultimately it was to kind of get to the point where it's just easier to build sites. And so we saw this kind of like major improvements across the platform from, Chrome and Edge, the Blink-based browsers go from a compatibility score from those 5 areas from 86 to 95. It's a total of 100. Firefox drastically improved, and then Safari had this massive leap from 64 to kind of 92 in terms of like how compatible they're, the experience that developers will have every day kind of building layouts on the web. That's not the complete compatibility story. Go and check wpt.fyi.com, FYI, to kind of find more details out. But it's a really nice area to kind of lean into on that side of things. And I think, ultimately as developers, the browsers start to focus on these things a little bit more, developers' lives get easier. It gets easier to build sites that work across all these different browsers. I think the other area that we looked into and we leaned into, and it's not the most exciting area at all. It's actually a very complex area, and it's not shiny, but it's important, right? Like Chrome has this overarching roadmap to remove third-party cookies from the web, and when you move third-party cookies, like that has a knock-on impact on a number of different kind of APIs and technologies. People are focusing kind of rightly or wrongly around kind of the advertising space. Which Google's obviously involved in on that side. But more importantly, as third-party cookies go, payments breaks potentially, identity might break, where you're relying on a third-party service to kind of authenticate and validate a user. Fraud detection might break. Like all these different things are kind of coming through, and the Privacy Sandbox is the project that's trying to coordinate and orchestrate and understand kind of the different use cases and the challenges that people are going to have. And so our big goal here is just to tell everyone to look at the roadmap of where we're trying to get to on privacysandbox.com and the timelines for when these things are going to happen, because we just want to make sure, like, when these cookies get removed from the web platform, or the third-party cookies in particular get removed from the web platform, you're ready. You're kind of not surprised by these things that are coming through. I think that's from like the business side of things, of just understanding the high-level piece. The other part, which is probably more relevant to you all here, is that the Privacy Sandbox has got a kind of obviously the technical component. And so we've launched a new area called on developer.chrome.com, called for the Privacy Sandbox in particular. And the idea behind that is it's supposed to give you more of a technical understanding and grounding into all the technical details that are kind of, coming through to new APIs and new kind of platform pieces. Like one example is like we're really worried about things like deprecations on the web as well. When you remove a feature, we've got this kind of reporting API which lets you understand kind of all the errors that happen inside every single user's browser on your site, And deprecations now kind of come into this space, and so we want to make sure that you've got all the warnings ahead of time so that you can kind of respond when you're coming through. But also you can also find out like all the newer APIs that are coming out as well, which are actually pretty cool. They make your life a lot easier, and we'll kind of cover some of those. But I think fundamentally the biggest thing that we wanted to get across is that actually some of this isn't it's a thing that you as web developers should care about. But it's actually a very principled process to how we're thinking about these different ideas, these new APIs kind of coming through. And so there's three obviously very distinct phases. There's a discussion phase, a testing phase, and a scaled adoption phase. And the whole idea behind this is like the community, the ecosystem gets involved and can provide input and feedback to every single kind of place at every single point. And then one example of the discussion phase is, I think people tend to worry sometimes like it's just the W3C and I can't get into the W3C, so I can't participate. Actually, the whole privacy landscape is run through community groups where different members and different parts of people like the ecosystem may be looking at payments, maybe looking at identity, maybe looking at kind of advertising. They've all got these different groups that they can kind of communicate in to have a real-time conversation to understand what's happening, where things are going, and also to shape the future of the platform, especially with regards to privacy. And then there's the other phase, which is this kind of like testing, right? And the idea behind this is like when an API has been kind of discussed and worked out, at some point it will get into the browser, but we have these two distinct phases, like feature flags for experimentation. Like they will be inside the browser, but you as a developer have to enable it, and it'll never get out to the rest of the user base. But like that's an ideal place and time to kind of give us extra feedback. And then there's this idea of origin trials as well. And I'd encourage everyone here to look at kind of the origin trial concept. But the idea is like we have an experimental API, but we need to battle test it in the real world, kind of get actionable feedback based on real user experience. And origin trials allow you to kind of turn on a kind of a development feature for all of your user base or part of your user base, and then kind of test it out and give us feedback. It times out, and so the feature will just drop off the web for a little bit until we're ready to kind of fully standardize it and look at this idea of scaled adoption. And then the final piece is just like, actually, when all the pieces are ready, we want to make sure you've got the time and the space to get all these, all the changes in place. And like one example of this is like, we're doing a lot of work to reduce fingerprinting on the web. And so we're kind of reducing the complexity of the user agent string. And it goes from kind of like having all the different platform versions in there and like the subversions of the browser into something that's a lot more simpler to go. And it's like, okay, well, developers need to understand that. We've got the guidance out. We've got warnings in dev tools kind of coming through. But really, there's also a kind of a complementary API called the Client Hints API that's supposed to give you more easy access to these kind of features coming through. And like the idea behind this is like whenever a feature is getting removed from the platform, we're able to replace it with a better, more privacy preserving feature as well at the same time. And so I think that the bit here is much more like the message is like stay on top of the privacy changes that are coming through the web. There's a lot of things happening in this space, and you might not think that some of them kind of impact you or you need to care about them too much. But like ultimately, we're going to keep talking about it every single event, every single time that we do this, because there are changes coming through and developers in the ecosystem are going to have to react as well. I think the other area that we were looking at as well, we had this kind of high level philosophy of like amazing applications. And I think in the past, it's all about these really cool APIs that are coming through. We've got file system APIs, we've got credentials, device position, speech recognition, like heaps and heaps of APIs coming through to the web platform. But it's like, as a set of developers, it's very hard to know whether they're useful, whether they're actually useful for your use case. And so I think one of the things that we started to change was how we're thinking about articulating like the advanced APIs story, rather than just feature after feature after feature and just like, oh my God, what's going to happen? Actually, we're talking about kind of use cases and end-to-end stories. And so one of the examples here is we worked with Kapwing, basically a video editor on the web, and they were just showing you kind of like these are the advanced kind of applications and experiences that you can deliver in a browser today without an install, without any user acquisition cost. You don't have to pay for things like the Play Store, but it's all with web technology as well. And I think the really nice thing about this as well is like they just articulated these are the different types of APIs that we use. They're not even brand new APIs. They're APIs that have been on the web for 5-6 years in some cases. But when you join them all together, you can create an amazingly complex experience. And I think that's where we're trying to go with all the APIs that we're working on. It's not just about the API itself. It's about where you can use it and how you can use it and demo in kind of that space. Because if you can't connect an API to a use case and something that you're doing, you're never going to use it at that point. And an example of this was just like, people talk frequently about WebAssembly and SIMD support and WebGL. And it's like, okay, well, how can I use it? And it's like another example is like Meet kind of integrated, WebAssembly into their overarching kind of, infrastructure. And they enabled kind of you to kind of like swap out the backgrounds and a whole bunch of other stuff, so that it's like you can run this inside the browser. They've got code that they can do it, but it's performant, it's fast at the same time. And I think then the other story behind this as well, I won't give the demo for this because I can't use Photoshop. I'm not that good. But one of our big stories was like you can bring very advanced applications to the web. Adobe brought Photoshop to the web on that side. And I think they're another example of a company that's taking advantage of the fact that you got real-time collaboration. You can just send people a link and you get them into the experience. And if you want to find out more, like web.dev/PS on the web, kind of gives you a little bit more information about the technologies and how they thought about this. But this was a story that we just wanted to tell developers, like it's now possible to deliver world-class applications on the web. You can kind of do it too. And I think that's where we're trying to get to overall as well. One of the other areas as well is like we've been thinking about, and it's two areas, like things like core web vitals and also design tooling, as well as like we want to enable it so that you as developers can just think about like, I just want to build a great looking experience. I want it to work well. I want it to feel good. I want users to be happy. And so, core web vitals is one of the areas that we were looking at as well over the past couple of years. And it's an area that we think you should still focus on, but it's basically 3 different metrics that you can think about loading performance, whether a kind of input is responsive, you tap on a thing and it actually responds, and that the user interface doesn't jump around all over the place as well. And so these were the first 3 metrics that we're able to quantify, maybe last year at the time. And because we're able to understand at scale how your users kind of perceive your site, we've been able to kind of integrate it into kind of things like potentially search ranking changes and a bunch of other things on that side. But the really nice thing behind this is that the developer ecosystem has kind of stepped up and started to improve the performance of their sites. And we've seen that, over 20% more visits to page visits in Chrome now meet all the kind of the criteria on that side. And I think just importantly, that means, as another number, like 60% of all navigations now meet the threshold as well, which is a pretty big change. The idea is that people's sites are getting faster, which means that people's experience of those sites is getting better at that time. Now, what I will say is like these aren't the only metrics that we're considering. There's more metrics kind of coming through in the future. And, it's like you can go and find that on web.dev on that side. But it's one of those bits of just like once we can start to quantify user experience, it makes it really easy to work out how you should fix your site as well. And I think that the bit for me around a lot of this is like, you as developers have to do a fair amount of work, but if you're using a CMS or another website builder as well, like those sites, those utilities have actually seen the value in kind of improving the performance of their sites and their experiences and their platforms to the point where it's like kind of automatic wins for everyone else. And so it's been nice to see. It's been really good to kind of see that coming through. I think the bigger bit though is like just generally for the developer ecosystem, like tooling is hard. Like we know that developers focus pretty much all their time on things like Lighthouse and PageSpeed Insights. And so there's a number of changes that have come through, and it's not in these slides, but I think yesterday we launched PageSpeed Insights or pagespeed.web.dev as this new kind of revision of PageSpeed Insights to actually improve the site score as well. And so the goal behind this is we know user experience from the field is one of the most important things to focus on. So it now puts that front and center for your for the sites as well. So the core web vital score is now part of the whole experience. I think the other side of this is like we know that developers struggle to do end-to-end testing. Like you can test a single page in isolation, but what does a user journey and user flow look like? Well, we've launched some tooling around this as well. And there's going to be way more tooling that kind of gets launched over the next year or so as well as we keep improving this. But you can test a whole flow end to end. And so the idea is that you can kind of record a flow and then play it back either inside Lighthouse. So you can kind of see the performance scores of every single step, or the accessibility scores, or SEO best practices of every single step in your user journey. Or you can also test these kind of experiences in an experimental tab inside Chrome DevTools as well. And so the idea behind this is that you can start recording, go through and then let it run through, but navigate through your site, it records the clicks, and then you can play that back either, as soon in Lighthouse or actually just directly inside the performance panel as well. And so I don't know why there's 2 slides in this one. It should have stopped. But the idea behind it is that you can record that, you can then put it into Puppeteer, and you can integrate it into more of your performance tooling as well, and then just replay it back. We think it's actually pretty powerful, and we think developers are going to really like it. And then I think one of the final pieces is this idea of this delightful design. like, I think one of the things that we want the developer ecosystem to think about a little bit more is that, user preferences are changing. Ignore the screen at the moment. I've got a problem with my Chromebook, so the display looks a little bit wrong. But things like dark mode, as an example, we've got kind of different kind of user preferences like reduced motion and a couple of different things coming through. We're basically seeing more developers or more users caring about developers respecting their choices over this year, and that's one of the things that we really want to push on as well. And it kind of gets a little bit more complex as well when you look at things like the Samsung Fold. The web is now on more devices, more different types of form factors, whether it's these foldable devices or multi-display. There's Android L, I think it was, for large screens where you can do split screen kind of web and a whole bunch of other stuff. Like the web is available on all these different devices, and we think that you as developers should have the tooling to be able to build experiences that are responsive to any device that the user is on at that point. And I think one of the tools that we're looking forward to kind of launching properly, and this is just a sneak peek, is the component queries API. And the idea is that you can go from, a big kind of like responsive design at the page width for the entire page. You don't have to have that. You can break your kind of, design up into a number of different components and be responsive inside a component without having to think about the entire page. And like, this is one of those features that it's actually on the roadmap to land in really, really soon. And it's like one of the number one features that web designers in particular have been asking for as well. And so we have a polyfill kind of coming through. It's looking pretty exciting on that side of things. And also the browser vendors are actually starting to implement it now as well, which is good. I think the biggest thing though for us, and this gets back into developers struggling to kind of keep on top of what the most important sets of things to work on are, is that we've also launched kind of complementary guidance called web.dev/patterns. And the patterns piece around this is it's pretty important for us, I suppose, on this side of things. Like, if the idea is like, I would like developers to be able to basically see kind of an output that they want to get to, and basically copy and paste it, and then start to use it in your site. And the idea behind this is, we might have this one. The demo we got here is called a pancake. I don't actually know why we did this one. There's better demos, things like carousels, as an example. We might do things like pinch to zoom and a whole bunch of other stuff as well. But it's one of those bits of just like, we want to make sure that when you go to the web, the web.dev in particular, you want to do something, you can put it into production as quickly as possible. And so we're really excited about all these. We've got design patterns coming through, and also performance patterns as well. And the two are really interrelated. If you can only achieve a design with a whole heap of JavaScript, you're not going to meet your performance criteria that you need to meet. And so we're trying to tell you, like, if you're doing a carousel, this is how you do it performantly. If you're doing pinch to zoom, this is how you can do it effectively as well. And so I'm really excited about a lot of this kind of these tools, like, or these pieces of guidance that have come out on that side. And I think the other piece as well is like, we're trying to make sure that you as a developer ecosystem, have all the core fundamental guidance that you need to be able to do your job. And so we launched a number of different Learn courses. So if you check out web.dev/learn, you'll see there's forms, progressive web apps, which we launched. We've got design. So Jeremy Keith, really great designer, has actually built a kind of a module or a course for us about how to build a kind of modern web design experiences. And so we're kind of making sure that developers have all the fundamental guidance to do your jobs effectively at that point. And I think finally, like, ultimately, like, one of my goals here is just basically to keep helping developers. I want to make sure that we're always at the front of making sure that you have all the tools that you need. And I know I mentioned it a little bit before, but like, this is the example of the page for Learn. Sorry, I'm going to sneeze. Web.dev/learn is the place where we really want to make sure that you've got all that you need to be able to be effective quickly. And I think finally, like, the last place as well is, like, I mentioned web.dev quite a lot, but that's the place that we're trying to tell the story for developers about what to focus on each year, help reduce the confusion, help you actually kind of achieve what you need to achieve. And obviously we've got our Twitter account, Chromium Dev, which you can kind of follow all the kind of the latest and greatest things that come through if you're really interested in the bleeding edge. And I think just finally, this is selfish self-promotion. I've also got a blog as well. If you ever want to kind of find out what I'm thinking about and kind of where I'm trying to take the web platform and our team, if you want that kind of behind the scenes kind of look that, that I just gave you today as well, and do it, I'd say follow that blog as well. So I know I'm kind of a little bit over, maybe exactly on time. Maybe do we have time for questions still?
Yeah, we still got some few minutes. I guess about 10 minutes for questions.
Yeah.
I see some questions that have been popping up on the chats.
Yeah.
So let's take a few of them. First one says you've mentioned something very important about privacy. So is this different with Google products that make it through with huge data collection?
No, I don't think it's that different at all. I think the bit that we're looking at is that we want to make sure that the web is not leaking definitely not leaking extra information out from the browser. And so there's just, the way I look at it is like the web was designed like 20 or 30 years ago, which didn't take into a number of kind of things that people are expecting for common right now. People didn't think about authentication, they didn't think about payments, and they didn't think about things like cookies coming to the web and what that might mean in terms of things like tracking. And so like there's a definite kind of move to reduce tracking across the board with all of this information. I think when you look at stuff like Google itself, like Google's going to abide by the same rules ultimately that's coming through, because it's the browser that is making these fundamental changes. I think in terms of the actual end, like Chrome itself, Chrome has, things like, history and a bunch of other stuff. There's like bits there. It's like those pieces of information are protected by the privacy policy. And like we expect kind of Google products to follow through. But I think the thing here is just like, especially from the web, the platform is getting improved and fixed to make sure that the information is just not leaked out at the moment. It's too easy to leak the information out. And like that means that all Google products and services will follow the same things because they run inside the browser. So I don't necessarily know whether that answers your question, but that's that's where we're kind of at least.
Okay, so we can go to the next one. The next one asks, where do you think should I start learning about Chrome Dev?
Web.dev.
Yeah.
Depends on what you mean. If you mean kind of just like web development with Chrome, like developers.chrome.com and web.dev are the two places. Obviously, MDN as well is another good example of resources.
Sure, yeah.
Building for Chrome, that's actually very hard. And so I would look at chromium.org as the place to work out kind of like how to think about building Chrome, how to download the source code and kind of get it all going on that side. That being said, there's not a huge number of resources and tools to understand how Chrome works, so you know where to focus. The one thing, or the two things I will say is there's a video series called Chrome University. I think it might be on the Chromium Developers channel on YouTube.
Chrome
University gives you a whole heap of kind of like behind the scenes look. Like if you're a Chrome engineer or you're trying to onboard as a Chrome engineer, like it gives you kind of a lot of the behind the scenes about like the philosophy about how rendering works, how security works, how all these different pieces work. So check that out. And I think another one as well is, and it's not on our channel, but it's a different one. There's a thing called BlinkOn, BLINKON. And that's the annual conference that the engineering team has to talk about future upcoming changes to the browser. That gives you a whole extra heap of information, which is just like most web developers never look at it, but it's a goldmine for how Chrome works and how we're thinking about Chrome works.
Pretty good. And those were pretty good resources. Let's go to the next question. Well, since Photoshop is being used now online, it makes the future of web looks very promising. So do you think it may even replace IDEs in the future? Like, do you think we can come to develop entire apps on the browser?
Yeah, I think so. It depends on whether if it's web. I think you can already do that today. VSCode.dev is a really good example. Yeah, it's amazing. Like I do pretty much in my blog. I tinker around a fair bit with my blog. You go to GitHub, press the period or the full stop key, and all of a sudden the editor kind of pops up and you're inside it. And so I think there's a bit there of just like we're definitely moving to that world of being able to kind of run on the web. We'll build on the web and run on the web. And I can't remember the name of the service. It's not StackBlitz. Maybe it is. But there's a service that allows you to run Node.js inside the browser. as well. I can't remember the exact company name around it, but like you're even able to kind of, if you can run those types of things as well, you can do full stack of web development just in the browser. If it's for things like Android apps, I'm sure that'll come. I don't think it's there right now, but as soon as you kind of start to run the kind of the JVM or kind of or whatever it is behind, maybe it's with WebAssembly, you could probably get there as well at some point. But web development, totally.
Yeah.
Great, brilliant.
Okay, thanks, Paul, for taking this one. One more. What would you advise someone who wants to keep up with the advances happening in web technologies right now? Any pieces of advice?
Yeah, I mean, webdeveloper.com. well, at least we put all of our information there. I think in terms of advice, like the web is so huge. Like, find an area that you're interested in, kind of diving into a little bit more, and kind of maybe focus there. Like, because when I look at it, is like you could say that web performance as an example. It's so deep and so complex and changing all the time that just keeping up with those is actually pretty hard, and staying on top of the industry. Keeping up with new APIs through the Fugu project, it's like super hard already. So like maybe pick an area that you're interested in, and then look at kind of either the commits that are coming through on Chrome. ChromeStatus.com will tell you everything that's coming out inside Chrome, well, as best we can. And so you can stay up to date on those and kind of hopefully keep it in a consumable amount of just like not too much information, but it's still kind of leading there. So yeah, ChromeStatus.com is a very good place, and then maybe pick an area that you're interested in the most to focus in that.
All right. Okay. We can take the next one too. What do you think browser diversity is a factor that helps Chrome develop better?
Yeah. I mean, sorry,
that was a pretty short answer.
Yeah. Well, no, I mean, the thing here is like if the diversity doesn't exist, like I'll rephrase it. Sorry.
Yeah.
I look at Safari and Firefox leading with the privacy narrative, right, as an example, right? Like they were the first ones to make a number of pretty significant changes to how the web platform should work. And you start to see developer demand, user demand kind of coming through. And we might not have seen that if it was just a kind of a browser monoculture. We might not have had that pressure kind of coming through. And I think in terms of things like, capabilities, like we push on capabilities a lot more than, say, Safari does. Safari's got different, priorities around rendering fidelity and performance and a couple of other things. Like we push Safari to do more for developers. Safari pushes us to do more as well and know what to focus on. And if we didn't have that diversity, we wouldn't have the kind of the checks and balances I think the web needs for a healthy web future. So yeah, it's super important.
Okay, awesome. Well, it's pretty good to see that diversity pushing everyone's forward. I guess we can take one more question.
Yeah, sure.
Okay. So that would be from me, I guess. You've mentioned that it's been pretty hard to have a moment for Chrome, like something specific to focus on from all of those features that have been asked for from users, developers. So are there any features that have been left out and in order not to be implemented for Chrome, at least for now?
Yeah, I mean, there's loads, right? I mean, there's a number of reasons why we might not have a feature coming through. We might not have the staff, right, to kind of go and land the feature. I like some of this, I'm trying to think of the different features that are kind of about there. We might not have all the staff in place. We might not have had the priorities as well. Like different teams have different priorities as well to kind of come through. I'm just trying to think of some, where we've struggled to get priority. Like a lot of the rendering stack originally, like layout and CSS, I think didn't get the priority that it needed to and attention it needed to help designers. And like, we focused on maybe, Fugu APIs or maybe kind of JavaScript capabilities that we probably missed some kind of like layout primitives that we wanted to try and land at that point. And so, yeah, so I'm struggling to kind of actually say, one feature that's not there. Like
That's okay. I mean,
yeah. I think there's a lot of challenges that happen. Like this is tough.
Of course.
This question as well is like, sometimes we just don't get the support to even land a feature from other browsers at that point as well. And so there's just a lot of different factors where it's like, you know what, if this is never going to land in another browser, we don't want it to just be inside Chrome like at all at that point, because developers are not going to use it really.
Yeah.
So like there's definitely lots of features that haven't come through, but it's a slow ongoing pace. Like the web of now versus the web of like even 5 years ago it's drastically different. And so like it might get there, but we'll see.
Yeah, maybe. Yeah, well, Chrome is not stopping, so it might be in the near future or just in the far one. So features will come. Yeah. All right, thanks a lot, Paul. I guess we should be good with these questions answered. Yeah. Thanks a lot for giving such a really good talk about and giving us insights behind the scenes, what's been there on the Chrome Dev Summit. Talking to us about the future of the web too. That was a really good one, and also for taking all of these questions. Yeah. And thanks a lot. Thanks a lot.
Yeah, it's good. It's good. Thank you for inviting me. So it's all
we were happy to have you, and we'd like to have you on more events at GDG Algiers too.
Yeah, just let me know, and I'll see what I can do.
Yeah, sure. Thanks a lot.
Cool. Thank you.
first place. First place goes to Effectivity!
Energy,
Big family.
community,
Paylaşmak,
home sweet home,
طغيان.
innovation,
opportunity,
Technology. Sharing.
motivation,
Proficiency.
progress,
Passion.
excitement,
life experience, achievement,
inspiration,
school, hope, خشونة,
Improvement.
Leadership.
friendship,
Fun. Motivation.
Connection.
innovation, love, creativity, family.
Teamwork.
sharing.
Things that matter.
And yes, we are cool.
First place. First place goes to Effectivity.
Energy.
Big family.
Community.
Paylaşmak.
Home sweet home.
طغيان. Innovation.
Opportunity.
Technology. Sharing.
Motivation.
Proficiency.
Progress.
Passion.
Excitement.
Life experience. Achievement.
Inspiration.
School. خشونة.
Improvement. Leadership.
Friendship.
Fun. Motivation.
Connection.
Innovation. Love. Creativity. Family.
Teamwork.
Sharing.
Things that matter.
And yes, we are cool.
Hello there. We're back. We're back on Devfest Day 1 with the second talk with Justin Reock. And the talk will be about developer productivity engineering, DPE. I'm really curious about the next big thing you'll be talking about in software development. So I guess we have Justin Reock with us, and he'll be the speaker of this second talk. Justin is a field CTO and Chief Evangelist at Gradle, and he's been focusing on developer productivity engineering lately. So he'll be speaking to us about that today on this talk.
Wonderful. Thank you so much. Let me go ahead and share my screen. Everybody, can you see that
Sure,
okay? Looks good.
sure.
All right. Excellent. Well, thank you very much for that introduction. And thanks everybody for attending and coming today to learn about developer productivity engineering. I'm Field CTO, Chief Evangelist at Gradle. There are two parts of our business. We have the open source build tool that I think a lot of people are familiar with, certainly within the Java landscape. And then we have our commercial offering, which is a set of enabling technologies that promote this idea of developer productivity engineering. And that's what we're going to be talking about today, really, is the practice from more of a vendor agnostic standpoint. We're not the only ones doing this. There's a lot of folks who are starting to really focus on this. Feel free to reach out on LinkedIn. That's where I do most of my networking. I'm also on Twitter, but I'm way more active on LinkedIn. Always happy to speak after the show or anything like that, and just to network in general, especially as hard as that is nowadays. It's actually interesting that we have all these virtual channels that have popped up to be able to network, even though the nature of it has changed a little bit. The breadth has actually, I think, increased a lot. So very happy to discuss things with anybody. So let's get into this. So here is, I think, the core and fundamental philosophy of developer productivity engineering. And that is that software development is a creative process. Okay, now it's also a scientific process. You are effectively making a hypothesis with the compiler or the platform. I think if I write this bit of code, it's going to do this thing. And when you get that positive feedback from the compiler or from the build system that says, yeah, it worked, it feels like this, it's joy, right? It's excitement. When we wrote our first Hello World program and it actually spat that text out in the console, that was a moment of excitement for us. We were learning. Okay, and so I think this is essential to the process of writing good code and being happy as a developer. And it's not just about Hello World programs anymore. Okay, this is a report released in October of 2020, a little over a year ago now. We are right on this prediction, looking at about 65% of the global GDP being fully digitized by the end of this year. We got less than a month, and we are on track for this. Roughly 2/3 of the goods and services sold globally now are going to be software services. Okay, that's staggering, right? That's a lot of Hello World programs. That's a lot of developers. Okay. Just recently, in June of this year, over Slack and using some improved deep learning software models, the remaining 8% of the human genome was successfully mapped. This now means that we have a full mapping of the entire human genome. The 8% was still left behind by the Human Genome Mapping Project, and it was just done virtually over Slack and then using improvements in deep learning and neural net software. All right, just another example of where a software innovation kind of is able to lift all boats in the harbor. By being able to fully map, by having a fully mapped genome now, we're able to start conceiving of predictive models that can do things like say, oh, a new novel virus is going to emerge in 2024 from the Bay Area. And so this is the vaccine that you'll need to fight that off. And then, you know, we'll be able to predict with accuracy, you know, how we can improve the state of medicine and really just improve the quality of life. So all of this is just sort of leading up to the notion that developers as a workforce and writing code are now one of the most, if not the most important workforce globally in terms of really achieving things that further human advancement, that really foster the advancement of our species. I don't know how else to really say it. So I think happy cows, good milk, right? We remember the old Mayfield slogan for those of you who may remember this marketing campaign. But I really believe that the essence of this is that the best code is going to be written by happy developers. And so we have, I believe, a responsibility to foster developer joy. But the opposite is happening. We have this bloom of software, but as enterprise projects and as enterprise software development becomes more and more complex, as the number of lines of code increase, as the number of developers contributing to the project increase, the overall performance of the tool chain takes a nosedive. Build times get longer and longer and longer. Developers have to wait longer and longer and longer for feedback about their code. That dopamine hit, that reward, for some companies can take hours. We have, you know, a very extreme case where before DPE standards were introduced to this company, they had a 20-hour clean build process. So they would cram in as much code as they possibly could on one day, and then the whole business is just shut down for a day while it builds. And what if they got something wrong? Or what if they have to debug that or troubleshoot it? And then we're back to square one. They've lost an entire day of productivity. That's not fun. That's not creative flow. That's not fostering developer joy or developer happiness. Not at all. That's introducing frustrations, slowdowns, and that's going to lead to bad code. So this quote, I think, adequately describes now the state of the industry. It's no longer the big beating the small, but the fast beating the slow. Okay? In other words, it's no longer these giant monolithic corporations that are the ones in charge of all the disruptions. It's really the companies that are able to get their products to market faster, listen to customer feedback, and get features out to the market faster. And that all starts with code. You know, I think there's been so much focus on DevOps, and we're going to talk about that in a little bit, that's really helped us unlock better deployment. But despite that, a lot of developers' calendars still look like this. Right, we're going to wake up, we're fresh, we're going to start coding, And then we're going to wait for our local build to complete. Oh, and something broke. So now I'm going to spend the rest of the day debugging the build failure, and maybe go to lunch. All right, fine. I'm going to go back, start coding again. Hey, my local build worked this time. Great, I debugged it, and I'm going to push it to CI. The tests are failing in CI. Now I have flaky tests that I have to deal with now. What's happening? The tests were fine in my environment. Now I'm going to spend the rest of the day investigating a flaky CI build, right? As glorious as software development is, we all know once you've been an enterprise software developer, you've been a professional, this is what your calendar starts to look like. This is what the workflow looks like when you're working on these big projects. Okay. So, this isn't, based on, some notions that we have, right? I mean, there's a lot of market studies that have been done, but this is some very compelling data right here, sourced by the Tech Validate research company. Overwhelmingly, companies asked, what pains were you feeling before taking developer productivity engineering seriously and before, making these investments, and overwhelmingly too much time spent waiting on build and test feedback locally or during CI. And then sure, insufficient observability of analytics on build and test performance and regressions. This is a story that I kind of love to tell. If you go and talk to a lot of development organizations and just ask them, like, what is your average build time? What's your average test feedback time? They're like, I don't know. We don't track that stuff. But, if you turn around and a customer of ours is BMW. And so I like to tell this story. When we were selling productivity engineering to that group, we asked the same question. Do you monitor the amount of time? Do you have those metrics? Do you monitor the amount of time it takes for code to build? And they said, oh, no. And they said, well, what if we told, the people who managed your factory that? Like, what if the BMW factory folks weren't paying attention to the amount of time it took and they're like, oh gosh, you're right. Wow. And, and it was kind of this aha moment. But I think a lot of people are kind of numb to these pains because we just think that's just an occupational hazard. It's just part of being a developer. You just have to deal with these frustrations. But the truth is no one's really paying all that much attention to it. Instead, they're paying attention to metrics like commit to deploy, which is important. Don't get me wrong. We need to understand how fast we can get the code out and how fast our release process is. And we have to scale that release process. And they're all very important things. But if you just ignore what happens far left of that, you end up with DevOps not really solving all productivity challenges. You still have developers who at the very beginning of the process are simply not given a workflow that allows them to create to their real potential. So that's why we think that developer productivity engineering is the next big thing in software development. We literally mean that it's the next set of bottlenecks to address after looking at the bottlenecks that have been addressed by things like DevOps practices, right? So if you look at all of these things together, go all the way back to just-in-time manufacturing, fast forward to now with things like DevOps. For a lot of you who've kind of studied these various practices, you realize that they all sort of come from the same root, right? Back in the mid 80s, there was the theory of constraints by Dr. Goldratt. He released a book called The Goal that became one of the most important pieces of business literature ever written. That would become the germ for the Phoenix Project, if you're familiar with that book, the Phoenix Project. And it's really just still about DevOps. It's about being able to say, okay, if we can convert, in the case of software, our code into money faster, we're going to have a more successful software business, right? Should kind of a no-brainer. DPE says, okay, that's true, but there are still constraints and still bottlenecks just in the process of writing code that are hurting the business and that are effectively keeping the business from producing features as fast as it possibly can. So that's where developer productivity engineering comes in. We take an engineering approach to productivity. So whereas we have maybe productivity management tools that are sometimes used that focus on behavior, lines of code and that kind of thing, this productivity engineering focuses on the tool chain, right? We're not really measuring developer productivity as much as we're measuring the efficiency of the tool chain for the developer. And we do that, we recommend doing this by using acceleration and analytic technologies. And I'll get into what some of those specific technologies are. But for all of this theory around the pains that developers still feel, the frustrations that they still feel, the solutions are surprisingly pragmatic. Oh, builds are slow, make them faster. Test cycles are slow, speed them up. No one's paying attention to those metrics, start collecting them, right? Now that you have those metrics, we can make sure that improving the build time once isn't like a one-shot deal, that we don't just go through and put this acceleration in place and then 6 months later the builds are slow again, right? We must kind of be vigilant and maintain data. We want to be able to detect flaky tests at scale rather than having developers have to deal with them, right? So for all this theory, the recommended approaches are pretty straightforward. To really underscore this idea that productivity engineering is very different from productivity management, or what you might call DPM, the focus is different. Whereas the focus of DPM would be on people and measuring people behaviors, the focus of DPE is measuring process and technology, right? The tool chain available to the developers. Whereas productivity management typically focuses its metrics on activity, project schedules, and things like that. DPE is really more about outcomes. In other words, did our story point capacity for our team, did our overall developer velocity just double as a result of perhaps putting in a build cache or something like that? We want to look at the outcome. SDLC focus for DPM is really on all phases, coding all the way out to deployment, but really DPE focuses on build and test, the developer experience, what they're going through as they're writing code. This will probably change a little bit. We're coming into a world where we have service mesh technology that's been made pretty easy, and now we can do blue-green releases and canary releases, and literally are able to like safely test in production now in ways that we couldn't do before. That'll probably mean that we'll need to start considering that to be part of the feedback that we would provide to developers. But for now, really our focus is on the build and test. And then the ROI, it's hard to measure DPM return on investment. It's just hard. There's so many variables. But with productivity engineering, it's actually very easy because you're tracking the metrics and saying, okay, well, we just took our build times from an hour to 15 minutes. You just did the calculation there. You just say 45 minutes of developer value, of engineering value. Of course, there's some diminishing returns, but it's a lot easier to prove ROI. In other words, it's a lot easier to sell this idea to your boss, which is great. So speaking of selling to your boss, DPE can be can be kind of felt at all levels of the organization when it's put in place properly. You really need executive support to do this in most organizations because it does, I believe, require a focus. You don't necessarily want people who are like development managers spending just a couple hours a week on productivity, right? It really deserves a focus. I mean, the mission here has to be, how can we make sure that our developers are as well supported as they can possibly be in their overall toolchain experience? And how do we really invest in that and maintain a focus on that, right? It's an attitude not of, is the tool chain fast enough? Is it as fast as it could possibly be given all vigilance and acceleration technologies and data, right? So as a result, it's really felt across the whole organization. Obviously, it directly addresses, developer and build engineer pains. So slow feedback and build cycles, slow test cycles, inefficient troubleshooting. Nobody likes going back and forth on Slack, copying stuff from Jenkins and console log output and system CLI output, right? So we believe there's a better way than that. We'll get that too. All of this bubbles up to anything that's VP or director level: faster delivery of products, faster increased time to market, decreased time to market, I should say, increased overall productivity and resource efficiency, quality of service, and then of course that bubbles up to C-level objectives like revenue, cost, and brand. Even flaky test detection. If you think about it, what happens when you have a flaky test? In reality, what do a lot of developers end up doing? Well, they run the test once. Oh, it's red. Run it again. Red. Run it again. Oh, it's green. Cool. It passed. Boom. Never going to think about that again. Push it down to the CI. Maybe it makes its way through CI. But the point is, the flakiness never went away. In all likelihood, that will manifest later as a production bug. Right? In fact, Spotify, who's a huge fan of DPE, they've written a lot of articles on their own. If you just go look developer productivity at Spotify, you'll find a ton of material that they've written. They can directly link like the blips and stuff that you get every now and then using their service to flaky tests. Like they can show you exactly the relationship between a flaky test and like a small service outage in Spotify, right? So brand is absolutely impacted by this too. Okay, so for all that theory, again, what are we trying to solve? Very straightforward problems here. Feedback cycles. This is a developer doing their thing, working locally, but this also applies to remote development as well as CI automation. They're dealing with a bunch of different type of feedback cycles. Some of them are okay. Some of them just take too long. We already talked about that a little bit. Build takes too long, test takes too long. Some of them take too long to fix. Okay, we get some type of failure, but it's really hard to chase it down, debug it, go back and forth with build engineers about what happened. Sometimes, and this is the worst, they could have been prevented altogether. If somebody was actually aggregating all the failure data up from all local remote CI builds across the organization, you'd be able to get a picture of what common failures developers are dealing with, how much time it's taking out of their day to deal with those failures, and then ultimately proactively cascade a process or a fix to make sure that developers proactively don't have to deal with that again. But no one's measuring this stuff, right? Same with flaky tests. Flaky tests, we have the Gradle build tool, the open source part of our organization, uses Gradle Enterprise for their own productivity, and they schedule regular flaky test days. And they schedule them ahead of releases so that they can literally go in, use the dashboard to eliminate all flaky tests in the tool chain before they go to release. And that's part of the reason that Gradle is such a stable tool. So flaky tests are just avoidable failures. And if somebody was aggregating that data up and dealing with it proactively, developers would never even have to feel it. And again, we know that this works. 81% of surveyed IT professionals would agree that DPE's impact on their tool chain makes their job more enjoyable. Right? I mean, it just shouldn't be too hard to believe that, right? I mean, you either are banging your head against your desk for 20 minutes waiting for a build to complete, or you're not, So, we kind of mentioned that there are pillars to this practice. I like to kind of talk about the pain that we're addressing, then the provided solution, and the outcome. So idle and wait time, developers waiting on test cycles and build cycles to complete. Well, we recommend 2 with a third technology that we're about to unveil pretty soon. It's in beta now, and I'll talk about it. Build cache and test distribution. Okay, and I'm going to go into each of these, so we won't spend too much time on this slide. It could be a real quagmire. I like to point out that as we move across the spectrum of different sort of pains and solutions here, we go from acute pains felt by the organization, like a slow build time, that's felt right then and needs to be fixed, or a failure that's hard to troubleshoot. And we move into more chronic pains felt by the organization. And we address all of these kind of across the way. So we start with this idle wait time, developers needing to get feedback from the system faster, great. Build cache, test distribution. Inefficient troubleshooting. Instead of having to gather data from console logs and Jenkins and output and this and that, we recommend what's called a build scan. And this is free in Gradle. It's part of the Gradle, which is part of the open source Gradle build tool. You could do this now. You could do Gradle build -- scan, and it's going to run a build scan. And what this does is takes all this information that you're usually having to pull together by hand and puts it all in one shareable report that you can link via URL. So if you're a developer and a weird failure comes up, you can link directly to that failure inside this whole build scan with tons of context, console log, and the infrastructure details and all the configuration switches used in the build and stuff like that, and just pass it via Slack to a build engineer. Or you can have the scans reports generate as part of your CI. This is actually a Jenkins plugin. Jenkins already has this built in for viewing build scans. So this is what we really recommend to deal with that pain of inefficient troubleshooting. Flaky tests and avoidable failures, failure analytics. We're recording all the failures from the build scans, aggregating them centrally, and then somebody's paying attention to them. Trends and insights, no metrics or KPIs, observability, no one really knowing what pains developers are feeling. And it's amazing the things that can get sussed out by this. Like we had, developers that were dealing oddly with a build that was like twice as long as some other developers in the organization. No one was really paying attention to that until we plugged everybody's build into the central metrics aggregator and then found out that we had these developers that were just sitting there, dealing with builds that took twice as long. Turned out it was their antivirus. The antivirus running on their laptop. As soon as they put a different antivirus on their builds, were cut in half. Build times were cut in half. Nobody would have noticed that. They would have just gone on dealing with that pain, and the business wouldn't have been as productive as it could have been, and all those things. And then finally, this is sort of a side effect. I don't even really necessarily like to call this a productivity pillar, but it is worth mentioning because these tools, these technologies are just literally asking the build system to do less work, there's a direct impact to cost. You reduce your cloud cost. If you're doing a lot of builds in the cloud, or if your CI is hosted in cloud or some sort of metered environment that's costing you money, build caching and flaky test detection and failure analytics detection, all of this stuff will literally ask that CI pipeline to do less. And so it's cheaper, right? So I don't necessarily like to call it a productivity thing, but it is a side effect of putting DPE practices in place. Okay, so that's the overview. Let's dive a little bit then more into kind of the technology behind this. So I've said this a bunch of times already, but very fast feedback cycles are important. I think that's just core to the overall creative flow, and that's what keeps developers happy in their work. But let's kind of put some numbers behind that and see what this can actually extrapolate out to. And there's a few things I want to point out here. First, let's just look at the raw numbers. A team of 11 with a 4-minute build time in the same unit of time is able to build about 850 times, let's say. That same team with only 6 developers with a 1-minute build time are able to, in the same amount of time, build over 1,000 times. Okay, so this team that's just a little over half the size of the other team is actually able to be more productive. They're actually able to create more builds, run more hypotheses, and get their code tested faster and out into CI faster, just because of that difference in the build time. One thing I want to point out is that hopefully you walk away from this talk understanding that the only acceptable build time speed is the one that is as fast as it can possibly be. But if you were to, before listening to this talk, look at a 4-minute build time, you might be like, oh no, that's great. 4 minutes, are you kidding? I wish we had a 4-minute build time, right? And you know, have organizations thinking that it's awesome, it's great, yeah, it's super fast builds. Until we realize with acceleration technologies, what if I could take that 4 minutes down to 1 minute? What if I could take it down to 30 seconds, 15 seconds? What does that do for your organization when it does this? Think about that at scale, right? 6 devs, even taking their build time from a minute down to 0.6 minutes with caching technologies or test distribution or whatever, that one small developer team is saving 44 days of engineering value a year. Extrapolate that to a team of 100, going from 9 minutes down to 5 minutes, a 4-minute difference, you're talking 5,200 days of engineering value return just by adding some acceleration technology to the build. Okay, so very, very impactful, just not something that most people think about. So build caching is a technology for delivering fast build and test feedback cycles. It was introduced to the Java world by Gradle back in 2017. It is part of the open source Gradle build tool. The commercial tool has options for remote distribution and things like that. Not just used by Java. Go has one now. I want to say Rust has one. So a lot of leading technology companies are now using build caches. And they can support both user local and remote caching for distributed teams. These are complementary to dependency caches. They're not mutually exclusive. A lot of people say, oh, we already have a build cache. We use Sonatype Nexus, or we use Artifactory or something like that. Not the same thing. There's a dependency repository, an artifact repository, a dependency cache, whatever you could call it, something like that. Not a build cache, right? A dependency cache has fully compiled artifacts, binaries that you'll download and package up as dependencies for your build. A build cache actually accelerates phases of the build itself. So in the case of Gradle, for instance, if you're familiar with the way that Gradle organizes work, it does so in the form of these incremental tasks, right? So maybe the first task is to lint the code. I'm going to run a lint on it. Then the next task is to run a check style to make sure that the style is matching with the organization. Then after that, I'm going to compile it. Then after that, I'm going to compile my test harness. Then after that, I'm going to run my test harness, right? So these are all like phases of the build. A build cache says, well, if those parts of the build haven't been impacted by a code change, there's no reason to run that part of the build again. We can just take the bytecode that was generated last time from the output and just reuse it. And that's exactly what a build cache does. It's elegant, the way that Gradle's is set up, in that it's completely stateless. It uses a cryptographic hash of inputs to the task to generate a cache key, and then it does a lookup for an output based on that key. So in other words, if I was doing a hello world program and I changed it to hello world or something, and then I were to recompile, well, of course the code changed, so it had to recompile it. If I changed it back to hello world, it would actually pull that from cache. completely statelessly because the inputs were back to where they were originally. Cryptographic hash key matches again, and I can pull that out from cache. Okay. Right now, Gradle will support doing this for Gradle tasks and for Maven goals. And then like I said, there's a number of other platforms, languages that allow you to do this type of build caching. In some cases, all you have to really just do is turn it on, and you just immediately start getting the benefits. That's the case for Gradle. So that's the first bit of enabling technology that we recommend. And again, this is straightforward stuff. The builds are slow, speed them up. How? Cache the tasks incrementally. For very large modular builds, this can have a huge impact. I mean, if you think about, multi-project builds with a whole bunch of tests and things like that, if you go and just change one small part of that project, the reality is for most people, you're sitting there waiting for that entire project to build. With caching, you may only be waiting a few seconds for that one bit that was impacted by your change to run. And then this is going to encourage better practice. This is going to encourage, smaller merge requests. This is going to encourage incremental changes because you're not worried that you have to cram a whole bunch of stuff in, and because that you're just going to be waiting for your build to run after that. So it really just changes your habits too, makes you fail faster, experiment more often, that kind of thing. It's good. Test distribution then can make tests even faster. So test output can be cached, right? So if you have a build with a lot of tests, the output from those tests can be cached, and then they won't have to rerun. But what if they do have to run? What if the test impact analysis tells you that, yeah, these tests have to run based on the code change that you ran? Well, we recommend then executing multiple stateless tests all at once in parallel. There's a number of platforms that let you do this. Ours included. Tests can basically just be horizontally distributed across a pool of test agents. These days, the use of cloud and container patterns can really help increase the performance ceiling there. Most of these are compatible with like horizontal autoscalers and Kubernetes, so you can use like comfortable and familiar, cloud or container scale platforms to actually handle the scaling of the agents. But any way you cut it, we really recommend setting up a test environment where a pool of test agents can run tests along many parallel threads. And again, just depending on how many tests your project has, how stateless those tests are, and really how much cloud compute power you're willing to throw at the thing. You can have you can see extreme payoffs from this. The open source Apache Kafka project has something like 20,000 tests in its overall test suite. It's a notoriously long build because of those tests. I've been able to get Kafka to build with a combination of caching and test distribution cleanly in less than like 3 minutes. I mean, it's crazy. That's running with like 20 pooled agents scaled in Kubernetes, right? And running with caching turned on, but it's much faster. So that's the acceleration stuff. I'm going to tease our last one at the end here. So what have we just done? We've dealt with build feedback cycles and test feedback cycles. Right? We just built, we had those slow. We sped them up using caching and test distribution. Now we need to measure things, right? Because what gets measured gets improved, right? We know this, it's an old business adage. Because without focus on the build behavior, cache behavior, things like this, problems can easily sneak right back into the tool chain. Binary management, additional CI agents, infrastructure changes, just installing something like a new annotation processor can all of a sudden double the time it takes for code to compile. Code refactoring, new office locations. We're all going to eventually be going back to the office, and bandwidth considerations are going to be in place. There's all these different things can change the state of the build. So truly, you can't make this just a one-shot deal. Go put the caching in place, the test distribution. Oh, great, we're done. No, you're just beginning. Now you've made it faster. You have to keep it fast. Build scan as a process then speeds up troubleshooting. This is the first observability tool that we recommend. provides this comprehensive shareable summary of the entire build. So you can almost see in the picture here, we have like a failure that took place in the build. We can see the console log. We can see test output, the infrastructure switches, plugins that were used in the build. And again, this is totally free. You can, if you're a Gradle user, you can do -- scan in your open source Gradle build tool today and get this scan for free. And it's very helpful. It's way better than jumping all around through Jenkins and the console log. Everything that you would think to give a build engineer or even a developer, if they were trying to troubleshoot, self-service troubleshoot their own build that ran in CI, anything you could imagine that you would need to have, the context for that troubleshooting is contained in this build scan. Right now, the Gradle tool will let you do it for Gradle builds, and there's also a free Maven plugin that's hosted out of Maven Central, nothing squirrely, that you can grab the XML, put it in your Maven project, and also run a build scan on Maven for free as well as part of the open source project there. Okay, so that takes us then into these other two pillars of failure analytics, trends, and insights. Failure analytics, I think one of the most important things that we reduce are flaky tests. You know, I've used that term a few times now. If you haven't heard that term before, you may have heard it called a non-deterministic test. This is basically a test that passes in one case, fails in another, with no discernible reason. And then we can break these down into two other types of flaky tests. We can call them verification or non-verification test failures. Verification test failure, these are some of the scariest because this is like an assertion. So you've gone to assert something in the code. I expect this API to return a calendar date. And instead it returned, I don't know, a picture of a bunny or something like that. Something totally off from what you were expecting, right? That's bad when a test like that is flaky because you had intent in that test. You thought you knew what the program was supposed to be doing. And yet, even with that hard-coded assertion, it's acting flaky. Okay, these are very problematic. They need a lot of debugging. If they're not caught in the first test, but they get caught later in CI, they can cause days of back and forth between build engineers and developers. And then they just, if they're not dealt with, then they make their way into the code in the form of bugs, right? So that's why I call them the pit of infinite sorrow. They're just bad all around. They're one of the biggest productivity black holes, and they can actually hurt the brand. To avoid them, we recommend failure analytics. And this is basically watching the behavior of all test failures across all builds in the organization, and even sometimes repeating those tests to detect flakiness right then and there. So really two things. It's finding flakiness further left in the process. And like I said, we actually recommend a practice of doing like a full flaky test day where you do nothing but focus on flaky tests. And then by looking for common failures within the organization and pinpointing them, we can eliminate them before developers even encounter them, which is just the best win, right? Really no way to say that one, except you're not wasting any developer time at that point. Also, you know, I mentioned before that there should be central focus for this in the organization. We like to call it a center of excellence for productivity engineering. Sometimes we've also called it a program management office of DPE or a DPE PMO. But we recommend that all of these metrics are centralized and that you have dedicated officers, and their job is just to watch these dashboards. When problems are detected, figure out what the problem is, and then proactively deal with that across the organization. And these are people who really should be dedicated to developer experience. Hopefully they have been developers and really understand developer pain, right? But we really recommend making this a focus in the organization. That's how it can really be transformative for the whole org. And then finally, machine learning will lead us to even better approaches. We have a new beta feature that's coming out soon. We're called Predictive Test Selection. This uses a gradient boosting machine learning algorithm to determine with some accuracy whether tests are going to fail or not, and then skip anything that's probably not going to fail. Because if it's just going to pass, why bother running it, right? So we're seeing pretty good results with this. Facebook and Google have also been doing this. It was coined originally at Facebook. I can't take credit for the original idea, but we are making it a pillar of productivity engineering. We think it's a very good approach to continue to eliminate even more work. So kind of in closing, I truly believe, and we are seeing this really bear out in the leading technology companies and some of the fast followers, that DPE will become standard practice because the world should foster developer joy. You know, as I mentioned before, we have one workforce lifting all boats in the harbor, and I believe we have a global responsibility to keep this workforce happy because it has a direct impact on all of our quality of life. Best organizations do build focused teams. So, you know, if you go look around at developer productivity engineering, you'll see that a lot of organizations are taking this very seriously and investing in it, and they're getting some of the best developers and the best talent in the industry as a result of promoting this practice. So kind of from here, you know, we do have a nice learning center, just all about the Developer Productivity Engineering Learning Center. We filter by learning objective there. So, you know, whether you're just starting, whether you kind of already are sort of doing some of this, you can find all types of materials here to learn more stuff. We do have a free ebook as well. It's like vendor agnostic. You see our logo on the front of it, but you don't see Gradle Enterprise mentioned at all. It's really just a handbook for productivity engineering practice. So, you know, if you think about this and what this could do for you, think about if you were the person who brought DevOps into your organization 10 years ago. What would that have done for your career, right? So DPE and productivity engineering, because it brings so much value to a business, it really can be a career track for you. You know, you could be something that you bring to your organization that provides tremendous value, and you can be a hero. So, you know, if you're interested in doing that, this book can kind of help you in that direction. And then, of course, you're always welcome to reach out to me. I hope you will. And I think we do have a couple of minutes for questions now.
Yeah, we do. We still got a few minutes. Thanks a lot for such an interesting talk, very insightful and very new to me, new concepts. Thanks a lot for introducing this concept to us. Especially, I believe it's very new. I believe it's for the Algerian community, especially. Well, we have some questions here. I'll take the first one. Do you think that developer productivity engineering will be used by small companies as well?
That's a great question. And, you know, it's so interesting because if you look at an interview that we did with a guy named Danny Thomas, who focuses on developer productivity at Netflix, you can actually see that on our website. It was like a month ago, I think. He made the point very clearly. He's like, look, companies like Netflix, LinkedIn, Twitter are the first ones to start doing this. But he said almost verbatim, he's like, but this is not a practice that's only for Bay Area, Silicon Valley tech companies, right? Any organization, small or large, that's writing software, which is pretty much every organization now, can benefit from this practice, right? So I really believe it's something that scales down and scales up. Netflix, you know, they take it very seriously. They have one productivity engineer for every 12 engineers in the organization. And they credit that for being why they can run such a lean organization. It actually surprises people that Netflix really only has a couple thousand engineers. It's actually not as big of an engineering team as people would think. Part of the reason that they're able to do that is because they're so streamlined. And they assign, you know, one productivity engineer to every 12 developers. But think about that scaled down. If you're a small team with 12 developers, you know, you hire one productivity engineer. Yeah. That should be plenty. Hire one person to focus on it. So I do think it scales to companies of any size and benefits any company that's writing software.
Okay, thanks for taking that question. The next one, what are some of the metrics used in measuring the effectivity of the tool process chain?
Great question. So we look at build time and test time, obviously. We look at failure rates. We look at flakiness rates. We like to take averages of those various metrics. And then in terms of what can you do in terms of kind of measuring the outcome or the relative success of DPE, those are actually felt kind of agnostically, usually in whatever KPIs you're already using. So like if you're doing Agile, for instance, and like you're doing real traditional Agile, you know, where you're calculating developer velocity based on story points and things like that, you'll actually see your team's story point capacity go up, right? That'll be an outcome. That team will be actually capable of addressing more story points, right? But it really just kind of depends. Like I don't like necessarily for DPE to direct the way that you measure those outcomes, because DPE and DPM or productivity management can exist very complementary to one another, but they kind of have their own place. You know, so I would say let DPE be the enabler of all that speed and greater efficiency, and let watching those metrics be the way that you determine whether the tool chain is efficient. But to determine whether DPE was successful, you have to look at the traditional metrics. You know, are we actually getting features out faster? Are we seeing less bugs? Are we seeing less flakiness, right? Those traditional metrics can be used to gauge the success.
I see. Okay, thanks for answering. We got one more question. I guess should be the last one. What are the costs of implementing DPE among the team? Do they need any special training to follow? I guess I may add to that question, take it further. I think everything comes at a cost. So what could be the cost of implementing DPE in a company?
That's a great question too. Yeah, and it's a very good point, because there is some investment obviously upfront that you have to make. In terms of like the training or special training or anything like that, I think the best training is to just have been a developer and kind of had that insight, like, oh, you know what, life can be better than this. Like I really think it's like an insight, like an aha moment where someone's like, no, a 5-minute build time is too long, and I don't accept it anymore, you know? So I think like it's really more about mindset. Like you have to really care fundamentally about improving the developer experience for those around you, right? It's an altruistic mission. I mean, it's an advocacy thing, right? So the costs really are first like getting that right person. Either you already know who that person is because that person's in your organization, has been recommending things like this, and no one's been listening to them, and now we're going to take them seriously, you know, or you go and find somebody who's been like a really good, you know, like DevOps engineer or developer advocate or somebody like that. The special training, I mean, you have to understand basic build engineering, right? You have to know what a build time is, right? You have to understand, you know, how to interpret signals from the data. So, okay, build times were averaging 5 minutes for our 1,000 developers yesterday. Now they're averaging 8 minutes. What happened? You know, and then it's usually not that person's job to go and diagnose what happened. Usually that person will then just go and make it apparent to the people in the organization who own the CI pipeline or whatever, like, hey, this is going on. Can you investigate it? So you can't be non-technical, but I also don't think you have to be like, you know, rock star, insane developer engineer, right? I think you can have this nice mixed personality of like caring about success and support and, you know, and experience while having enough technical chops to really understand and be able to translate that stuff to the developer experience. And then, you know, again, you can take as much or little of this practice as you want and build it up in your organization. You could start with build caching like today, and then slowly start aggregating more stuff up. So it's not one of these things where it's like where Agile, everyone's always very serious about, oh, well, you can't just partially do Agile. You're either doing Agile or you're not. And they're right, you know, but it's very regimented. With DPE, you can bring in pillars over time. So.
Yeah. All right. Okay. So it's more about the mindset. So I see some comments saying that we hope that we see such mindset, especially in the Algerian tech companies here in our ecosystem. So hopefully we will reach that. Thanks a lot, Justin.
Yeah.
Thanks. Yeah, sure.
My pleasure. Thank you, everybody, for
Thanks a lot,
time.
Justin. We really had good insights about DPE today from you, and we would love to have you on our events in the future at GDG Algiers, because we really enjoyed your talk today. Okay, so I guess would you like to add any last word?
I think that'll do it. It'd be my pleasure. I would love to come back and speak again. Thanks so much. It's been a wonderful audience and a really great platform.
Thanks a lot. Thanks, Justin. So I guess that should be it for today, everyone. Thanks a lot, everyone, for tuning in today. We hope to see you tomorrow because we still got some more talks coming in. All right. Okay. See you tomorrow.